Welcome back, everybody, and off we go. More Q&A. Winter 20, test 2. We have the following molecules in order of increasing basicity. So these are all bases. We need to talk about their conjugate acids and their pKa's, don't we? It's not as straightforward as it looks. These are all the most stable resonance forms, which doesn't mean they look like this before they lost their protons. So this is the resonance form of its conjugate acid here, and I don't know what I just did. I'm finding new features all the time. Okay. We've got that. And that is the enol version of a, well, let's see, what is it the enol version of? And I got the squiggle there. Carbonyl NH. And let's tidy this up over here. So this business end here had an OH up there. So you're thinking, some of you are thinking 17. No, that's not the more stable form of the original molecule. Just remember this, please. If you have a choice of two tautomers, which these are, they're related by tautomerization. The one with a more stable pi to an oxygen is always the original molecule. This is the tautomer that's not as stable. So what we're looking at here is a amide with a pKa of 17. And since that came up, I'm going back to page 1 of my documents today, previous video segment, and we have a 17, which we're going to sneak in over here. And that's a 17 as well. And it's an amide. All right. So we're back to page 3. We're trying. Here we go. This is it came from this species here. OH, double bond here, which is the tautomer of something that we had on that page that I just had open. Alpha to 2 carbonyls, pKa 10. And this came from just one carbonyl. Well, let's be consistent here. Just put the H on it. It looks like an enol, but we know enols come from the more stable pi belonging to the, in this case, ketone. And the pKa of that alpha position is 20. This also on that original document we looked at the start of today is from this one, which came from this one. Ester with an H, alpha, pKa 25. The words competing resonance come into mind once again. So let's do pKb's in blue. pKb's right here for the molecules that were in the original question. 14 minus 17, negative 3. 14 minus 10 is 4. 14 here minus 20, the conjugate acid's pKa. 14 minus 20, negative 6. 14 minus 25, that's a negative 11. Strongest base. And they are in the correct order right now, but backwards, aren't they? Wait, no, they're not. I totally apologize. Weakest is the highest number, and that's 2. So I would want to say put 2 first. 2 less basic than the next highest number is this one. The one's closest to, well, just highest. 1. And the next highest is negative 6 is 3. And the lowest number, strongest base, 4. There we go. Then we had a similar question down here. I'm going to just address the issue here. I think the previous example talked about why did we change it to COO? Well, put the H on it and you're at the situation you're at here. You have an enol. That's not what it started like. No, it started like a ketone. Same story here. Started like a ketone, pKa 20, like the student wrote. So this has a pKb of 14 minus 20, negative 6. This one, I think if you just read her question, the answer's actually hidden in it. She correctly noted that if there's an H here, the alcohol acid would have a pKa of 17. I agree. So why we use pK of alcohol, not for ketone? Well, what H came off first to make this molecule? Here, we have a choice of alcohol and ketone with an alpha H. Which one is coming off first? 1,000 times faster. Is it the 20 or the 17? And the answer is 17 comes off before 20, so that's why we use the 17 and not the 20. Okay. And I think we covered that. And there's more. I kind of grouped her pKa questions over here. Why the answer is C, not B? Well, in this one, take a look at the ability of this molecule to resonate all the way. That's all black. I'm sorry. And look at that. That's perfectly nice resonance, isn't it? And you can't, this is sp3 over here. You can't resonate through this position at all. sp3. You can't get from this O minus to the other O minus. So yeah, you took off a 20 before. This is the 20 because it was alpha to a single carbonyl before it came off. And you took that off before you took a 10. Why was that a 10 here? Here, O methyl. This one's 20 and this one is 10. Which one comes off first? The 10. And it can resonate to this one, or it can resonate to this one. And if I have to choose which one I like better, I say I don't like the one where this can't resonate with the carbonyl anymore. I like this one a little better. This O normally wants to resonate with the carbonyl, and in this resonance form, that's not an option. In this one, it is. It can resonate up there. So yeah, C is from the correct pKa, the 10. So is E, but C is a better resonance form because the O can still resonate over here. I think that does this page. I think that was a nice little mini segment. We will stop here and come back very shortly. See you soon.